Hello, grade 10. In this video, I'm going to solve some of the exercises in the book that are very important for our long quiz next week. Okay? So, I want you to pay attention because every solved exercise in this video is required for the quiz. And sometimes I might solve something that's coming exactly the same in the quiz. Okay? First of all, I'm going to start with exercise 14, where we have this expression and you are asked to simplify this expression in order to get a constant to be determined. So the answer of this expression is going to be a constant number. What's the first step that you have to do? Every time you see cotangent squared or tangent squared, you have to replace them. So the first step is to replace cotangent squared by cosine squared over sine squared. Okay, so instead of cotangent squared, we wrote cosine squared over sine squared. And now the whole expression you can simplify sine squared x by sine squared x. So what do you get? You get cosine squared over 1 minus sine squared. What's 1 minus sine squared? It's cosine squared. Why? Because cosine squared plus sine squared equals 1. So cosine squared equals 1 minus sine squared. Okay? And now cosine squared over cosine squared equals to 1. And that's the constant that you have to determine. Okay? Now let us go for another expression. You have cosine squared plus 1 over 1 plus cotangent squared x, and also it's a constant to be determined. As I told you before, every time you see cotangent, tangent, you have to replace them directly by what do they express. So cotangent squared x, it's also cosine squared over sine squared. And now what do you do in the denominator? You do common denominator. Okay, so the common denominator will be sine squared, so 1 is replaced by sine squared over sine squared. And now what do I have? Sine squared plus cosine squared, which is 1 over sine squared. And now we do far near, so we get cosine squared plus sine squared, which is 1, and that's the constant to be determined. And now let us start solving something else, which is reducing the following expressions. Before we start, the first thing that you have to do is to draw the circle. Okay, don't forget, all students try cheat. We have here 0 or 2 pi. Here we have pi over 2. Okay, pi and 3 pi over 2. Okay, now let us start with the first one, which is sine 4 pi plus alpha. You know that 4 pi is, it takes you again to 2 pi, so we can say that 4 pi is 0. So the only thing that's left is sine alpha, and sine alpha, it's in the first quadrant, which is all positive, equals sine alpha. Okay, now let us take another example. We have cosine alpha minus 2 pi. You know that it's not ordered in the correct form. We don't have something which is alpha minus 2 pi. It's minus 2 pi plus alpha. It's the same thing because minus 2 alpha in all cases is 0. So we have cosine, we have cosine alpha. Cosine alpha is cosine alpha because in this quadrant cosine is positive. Now let us take another example, which is alpha minus pi. As I told you before, it's not ordered in the correct form. It should be pi minus alpha, which means it's the negative. Okay, so it's the opposite. But what I know that, pay attention to only, this is the only case that you have to pay attention to. You know that cosine minus alpha, it's the same as cosine alpha. So the negative form in this case, it doesn't matter. Okay, so I can write it again as cosine pi minus alpha. I can flip them directly without changing the sign, because cosine minus alpha, it's cosine alpha. Okay, so I write it as it is, cosine pi minus alpha. Now I discuss Pi minus alpha, in which quadrant? It's in the second quadrant. So the only positive line is sine. So cosine pi minus alpha is minus cosine alpha. Sorry. Let us continue. Now we have tangent 3 pi over 2 plus alpha. What's 3 pi over 2 plus alpha? It's in this quadrant. Cosine is only positive, so the answer of tangent is negative. It's negative cotangent alpha, because as we said before, pi over 2 and 3 pi over 2 changes the trigonometric line. So if it's sine, it becomes cosine. If it's cosine, it becomes sine. If it's tangent, it becomes cotangent. If it's cotangent, it becomes tangent. Okay? Let us now continue. Now we have an expression, sine alpha plus pi over 2 plus cosine alpha plus pi. Here the order, it's not really important because alpha plus pi over 2, it's the same as pi over 2 plus alpha because both of them are positive. Pi over 2 plus alpha, we are in the second quadrant, so the sign is positive. But because we have pi over 2, the sign becomes cosine. Now cosine alpha plus pi, it's the same as cosine pi plus alpha. We are in the third quadrant, so this is negative. So we have cosine alpha from the first expression and minus cosine alpha from the second expression. And now cosine alpha minus cosine alpha is 0. Now let us go to number 6. And in number 6, what do we have? Sine 3 pi over 2 plus alpha, cosine 27 pi over 2 minus alpha, sine 3 pi plus alpha minus cosine 7 pi minus alpha. I'm going to solve each one alone. The first one is very easy. We have 3 pi over 2 plus alpha, so we are in the fourth quadrant. So this is minus cosine alpha. Okay? So we are done from the first one, it's minus cosine alpha. The second one, we have cosine 27 pi over 2 minus alpha. This doesn't work out. So I need to reduce this fraction as I learned in the first lesson. So 27 pi over 2. We can tell that 27 pi over 2 it's 26 plus pi over 2. Why? Because 26 over 2 is 13 pi. So I did nothing to know the lines. So we take 27 pi over 2 as 28 pi over 2 minus pi over 2. Okay? So I write it 28 pi over 2 minus pi over 2. Now sine 3 pi. 3 pi is written as 2 pi plus pi. 7 pi is also written as 6 pi plus pi. Till now, this is 0 because it's 14 pi. This is 0 because it's 2 pi. And this is 0 because it's 6 pi. So now I have minus cosine alpha plus cosine minus pi over 2 minus alpha, sine pi plus alpha, cosine pi minus alpha. Now I can tell the answer directly. As I said here, cosine minus alpha, it's the same as cosine alpha. So I just pretend that minus pi over 2 minus alpha, it's the same as pi over 2 plus alpha. Okay? Pi over 2 plus alpha, cosine here is negative. So this will be minus cosine alpha, the first one stays as it is. As I told you here, it's pi over 2 plus alpha, pi plus alpha, pi minus alpha. I just wrote one more step to tell that cosine minus alpha, it's the same as cosine alpha. Okay? Sorry, just a second. So just to tell that minus pi over 2 minus alpha, it's the same as pi over 2 plus alpha. What's pi over 2 plus alpha? I told you the answer will be minus sine alpha. Why sine? Because whenever I have pi over 2, I have to switch the trigonometric line. So minus cosine alpha from the beginning, this is minus sine alpha. Now sine pi plus alpha, we are in the third quadrant, this is negative. Okay, so minus sine alpha. Pi minus alpha, also the cosine is negative, but because we have negative in front of cosine, so it becomes plus cosine. Now what will happen? Minus cosine alpha and plus cosine alpha will go, and minus sine alpha minus sine alpha, we can add them, so it's minus 2 sine alpha. And now we have number 7. Also, I'm going to draw the circle again. No, let us draw a better one. Okay, again. So this is the circle A, S, TC, and we have pi over 2 and pi. Okay, let us start with the first one. So we have tangent pi plus alpha, cotangent alpha minus pi over 2, sine alpha minus 3 pi. This is okay. I can find the value directly because pi plus alpha, it's the tangent quadrant, so the answer of this one will be tangent alpha. Now it's not written in the correct form, and cotangent alpha, it's not the same as cotangent minus alpha. So I have to multiply it by a negative outside to flip the positions, so it becomes pi over 2 minus alpha. The same thing for sine. I have to multiply it by minus in order to switch their positions, so I get 3 pi minus alpha. Now, what's the pi over 2 minus alpha? We are in the first quadrant and cotangent is positive, but its answer is tangent alpha minus tangent alpha. Now, 3 pi, it's written now as 2 pi plus pi. 2 pi is 0, so it becomes minus sine pi minus alpha, okay? And for the numerator, we multiply them, we get minus tangent squared x. Now, pi minus alpha, we are in the second quadrant where the sign is positive, so the answer will be sine alpha, but we already have minus in the beginning, okay? So this is the answer. Minus goes with minus, so the answer is tangent square alpha over sine alpha, but it's not in the final form. We can write the tangent as sine squared cosine squared, so we multiply the numerator by the far by far, near by near, so we get sine squared over cosine squared sine alpha, and we simplify sine squared with sine alpha, so the answer is sine alpha over cosine squared alpha. I just want to add something which is related to our quiz, so pay attention very well. We have sine alpha over cosine alpha, cosine squared alpha, right? I want you to know that we can write this as, okay, you know that cosine squared is cosine alpha, right? So I'm going to erase this squared and I'm going to write it as cosine alpha. I can take sine over cosine, it's tangent, right? So I will get tangent alpha over cosine alpha. So you can switch their position according to what do you have. Suppose I have, okay, pay attention to what will happen right now. Suppose we have sine alpha, okay, plus cosine alpha over sine alpha. What do you do in this case? What can you do in this case? Of course, not every time you can do this. It depends on what they ask you, they want the answer is. This is very important for the quiz, huh? So pay attention. So I can write this as sine alpha over sine alpha plus cosine alpha over sine alpha. What did I do in this case? You know that the same denominator is for both of them. It's for the sine and it's for the cosine. So I split them. In this way. Now sine alpha over sine alpha is 1. And cosine alpha over sine alpha is what? It's cotangent alpha, right? So the final answer is 1 plus cotangent alpha. When do you do this? You do this when they ask you, show that, for example, this expression is equal to 1 plus cotangent alpha. You should do, for example, of course you will have in the final answer this one, and then you split them in order to get 1 plus cotangent alpha, okay? And here we go for an important question. We've already done this in the short quiz, but I'm going to make a revision. How do we solve this? Okay, we have 25 tangent square x equal 144, and you need to calculate the exact value of this expression. So I need cotangent, sine, and cosine. But first, let us calculate tangent. So tangent square x equal 144 over 25. What did I do? I take 25 down. And now tangent x is equal plus or minus radical 144 over 25. So it's plus or minus 12 over 5. But because we are in the second quadrant, so the tangent is negative. minus 12 over 5. Now, after calculating the tangent, I can calculate the cotangent, because the cotangent, it's 1 over tangent, so it's enough to flip the fraction, so it's minus 5 over 12. Now we are asked for sine and cosine. Of course, this relation here I'm going to give you as a given. You are not asked to study this expression. So cosine squared x equals 1 over 1 plus tangent square x. So in this way, I'm going to calculate cosine. I just replace the tangent by its value, and I do same denominator. Then far, near, so cosine squared is 25 over 169. So cosine x equals plus or minus radical 25 over 169, which is 5 over 13. And in this quadrant, cosine is negative, so cosine x equals minus 5 over 13. Now, how do I calculate the sine? From cosine, we have only one relation, which is cosine squared plus sine squared equals to 1. So sine squared equals 1 minus cosine squared. Sine squared equals 144 over 169. We do the radical, but sine should be not positive, so sine is only line which is positive because we are in the second quadrant, so it's 12 over 13. Now I can calculate E. How? By replacing cotangent by its value, the sine by its value, and cosine by its value, and you put this, all of it, on the calculator. It gives you the final answer. Okay, now in exercise 34, look at this expression, and you are asked to show that E equals 1 over 2 cotangent x. Okay, this is very important. So what do? E equals cosine squared, and what you have in the denominator, you need to expand them. So cosine times cosine, cosine squared, cosine times sine is cosine sine, cosine times 1, it's cosine. After multiplying all for all, now I will start simplifying. Sine x goes with minus sine, cosine goes with minus cosine, cosine squared plus sine squared is 1, minus 1 it goes, so what's only left is cosine squared over cosine x, sine x, cosine x. You can add these two, so it becomes 2 cosine x, sine x, and now you simplify, you get cosine x over 2 sine x. Till now you are done. If the question only simplify the expression, but because they ask you to show that E equals 1 over 2 cotangent, that means you have to continue. What's cotangent? It's cosine over sine, right? Cosine over sine is cotangent. So we have 1 over 2 cotangent. Sorry, the cotangent, it's not here. Okay, cotangent should be here. Cotangent x. So it's 1 over 2 cotangent x. I'm not going to continue the question because I've already solved similar to these. We have here, for example, sine x, and you need to calculate cosine from sine squared plus cosine squared equals to 1, and you need to calculate tangent, it's sine over cosine after all. And then they ask you to find the value of E. You know that E is 1 over 2 cotangent, so after solving cotangent here, you replace cotangent by its value. Okay, so E is 1 over 2 cotangent x, but cotangent x, you can calculate it from here and then you replace it in E. Okay, so this is very important.